Hi, everyone, and welcome to the Snapt webinar on real-world load balancing. We are super excited to have you on board with us today. Today, we're going to take you through what load balancing is, particularly focusing on today's virtual and DevOps-focused environments, as well as why you need load balancing and how you utilize and deploy it. First of all, just to kick things off, you'll notice that you have several handouts in the webinar which have more detail on Snapt products and load balancing in general. At the end of the webinar, you will be able to ask Dave and Jake, our speakers today, any questions you've had as well, using the question and answer feature in the webinar. If you need any direct help or want to engage with the Snapt team, please remember you can contact us at sales@snapt.net at any time. Now, to kick off the webinar, we've got two presenters with us today who I'm super happy to introduce to you. First off, Dave Blakey founded Snapt in 2012 and currently serves as the company's CEO. Under Dave's leadership, Snapt achieved a 400% annual growth rate in 2014. Snapt is a high-end provider of application delivery software, including load balancing for companies of all sizes. Snapt provides load balancing, acceleration, and protection to more than 10,000 clients in 50 countries. Next up, our guest speaker today will be Jake Nutt. Jake is a systems engineer and works at New Analytics. Founded in 2006 by collections industry veterans, New Analytics serves a range of clients across multiple industries, empowering them to better manage collection agency vendors and maximize debt recovery. New Analytics provides data management that gives you control, account placement for maximum potential recovery 24/7, auditing of each collection vendor performance, and reporting with a click of a mouse. Great, so those are the introductions. Dave, if you can take it from here, let's kick off the webinar.
Great, thank you, Nadine, and thanks, Jake, for joining us as well. So, as you all know, this is a webinar on load balancing in the real world, what, why, and how. So we're going to take a look at what load balancing is at a basic level and why you need it, but also why you need it in today's environment, and what application delivery control is, the difference between pure load balancing and that, how you deploy these types of technologies. We're going to hear a bit from Jake on how they use Snapt in their environment, and then we can have a discussion, as Nadine said, around the Q&A. So if you do have any Q&A questions at any time, you can ask them right away. Just type them in the Q&A window, and then we'll answer as many as we can at the end. So to get started, the first thing is to address the business challenges that we look at when we look at load balancing and ADC in general. And this obviously isn't just Snapt, but particularly our clients and other vendors like us. Really, it's about scalability, redundancy, and flexibility. So we're looking at challenges in businesses where they need to maximize performance. So that has two sides to it, really. They need to scale, expand their operation, add more servers, handle bursts of traffic, just handle regular growth, whatever it might be, as well as enhance their performance to their users. So ensure that users are getting a quality experience, that they're not suffering high latency, that services are not slow, things like that. The second is obviously linked to guarantee availability and scale. So to ensure that their services stay online, these are obviously often hand in hand. As soon as you need to have a service that doesn't fail, you generally also need to scale it, or vice versa. And to be able to grow fast, to scale quickly. And the final one is to ensure security. So protect this business asset of yours and your servers that run it, as well as protect your users that use it. And so these are kind of the pain points and the challenges within businesses that cause them to look at a load balancing solution as their business grows, or as they begin to develop new needs in their business, essentially. So the first thing is to explain load balancing as a concept. Now, what I've got here, you'll see is a diagram. of a typical website deployment. Now you'll notice I use a website as an example across this entire webinar. And it's a pretty good example because it's something that's common to basically everyone and everyone understands it. But the other thing is that almost all traffic that we deal with nowadays is web traffic, whether it's the backend to an API, the interaction between a mobile app and some server. It's all traveling over what we call web traffic, so HTTP or HTTPS, just like you would in your browser. Obviously, different instructions, different requests, but similar traffic. So websites are a great example to look at. And also there's some of the most value you can add to websites. So in this example, you can see here, we've got a website at the top and we've got 3 clients at the bottom, Jim, Bill, and Ted, all trying to connect to the website. And this is pretty typical for a company when it's first starting out, or for a project within a bigger company or whatever it might be. You have a single web server running your website or business property, whatever it might be. And you have users interacting with that, and they connect directly to the web server and it responds directly to them. Now, what this doesn't give you is any kind of resilience against failure. So if that website fails, that web server fails, all of your users are disconnected and your site's offline, obviously. At the same time, if too many users try to log in, the web server will become slow and you can't scale it out. So those are that's the problem where you then begin to look for a load balancing solution, is to say, well, you need to have multiple web servers because you need to be able to handle a failure on one, and you need to be able to scale horizontally. So what you do is start to set up more web servers, and then your users can connect to multiple servers, obviously, and you become fault tolerant. However, as soon as you do that, you need a device or a program or something, and this applies to being in the cloud, bare metal, VMs, whatever it might be. You need something that tells Jim to go to server 1, Bill to go to server 2, and Ted to go to server 3. And if server 3 is down, to make sure that Ted doesn't get on server 3. So as soon as you start to scale out the service, that's when you need a load balancer, and that's what that does at its very core. So a load balancer sits in front of those, and your clients and users in that connect to the load balancer, in this example Snapt, and it then connects to your web servers for you. So what it will do is accept a client's connection, make sure that the server it wants to dispatch that client to is online, that it's performing quickly, is it the appropriate server for this content, all that type of stuff, and essentially then select the best option and send that user there, get the response from that server, and then send that response back to the user. So what this allows you to do is easily scale out horizontally, grow the number of web servers you have, and handle 1, 2, or 3, etc. web servers failing, as well as simple things like taking web servers off for maintenance and so on. And it's a bigger problem nowadays in the cloud than people realize. More and more people are moving to the cloud, but you still need the system that handles this, because it's not only about dispatching users, which continues to be in the cloud, but also monitoring performance. We have lots of users that have high failure rates in cloud providers. They have latency on certain servers, things like that. So as you start to add more and more value and your product becomes more and more critical and you want to deliver a better and better experience, it's not just if a server is online or not. Is that server responding very quickly, or is it perhaps slow? Is there a problem in that section of the network? Have there been errors whenever people have tried to run reports on that website, whatever it might be? And so you start to see a lot more value from your response monitoring and your health checks and your reports and your proactive alerts and all that type of stuff, as opposed to just sending users to multiple web servers, right? You also get, obviously, the ability to do much more advanced load balancing. So this is what we call ACL-based routing or rules-based routing. So in this situation, this is a simple example, but you can imagine how complicated it gets. You might have a setup where you have a very high traffic website. And you've decided that all of your content for your page is going to be generated by Microsoft Server. And you have a cluster of Microsoft servers to drive this. But you've also decided that it's more efficient to drive downloads off a cluster of Linux servers. So you want to do things like say, okay, if the file ends in .zip, I want to send these people to my Linux farms. If it ends in .aspx, I want to send them to my Microsoft one. And that's just a simple example, but it can obviously get quite complicated. If the whole of site 1 is down, I want to send everyone to site 2, but if site 1 is up, don't send anyone to site 2. Things like that. At the same time, let me also accept people that are looking for my Exchange domain and send them to the OWA servers. And as you can imagine, it obviously builds out into a much more complicated system. Now, this is much easier to do with load balancing, and you can have finite control over how these things work and handle the failure situations for these things and so on. And that's where kind of load balancing eventually evolves into, is what we would call intelligent ACL-based routing. So deciding where the best place to send the client is based on a whole set of rules that are, business cases for your system, your application, or your service, whatever it might be, intranet, anything. Now, ADCs, the difference between an ADC and a load balancer is something that we're going to talk a bit about here as well, because they're actually very similar. And all ADCs have load balancers, but not all load balancers are ADCs. Now, as you can see from the previous page, you wind up with a situation where your load balancer is suddenly your monitoring device, reporting device, it's your central management system, it's connecting to all your servers, it's dispatching your users. And the second situation, like I was saying, is that most of your traffic is web-based, whatever that might be. Even like the Exchange example I used, Outlook Web Access is all run over web. So you have this infrastructure management side of it, where you want to proactively monitor these business critical services. You want network visibility, you want reporting, you want diagnostic tools, all that type of stuff. And you want to deliver applications. So application delivery is really about not just ensuring that an application is online, but that you're also delivering the best experience, most optimized and secure and safe version of that application, right, of this business critical service you have. And the realization of that is really where an ADC begins. We'll go into it in a bit more detail just now. Now, we often get asked how you deploy a load balancer, where it sits, how it normally looks in the network. So I think that's important to say. The first thing is, with the balancer, you can deploy it in any virtual environment with the Snapt Balancer. So it's software only. You can run it in any public cloud, private cloud, bare metal, whatever it might be. And you'll typically have an active and passive load balancer with floating IP addresses between them. So you'll have an IP that always sits on your master device, and should that fail, that IP will transfer to your slave device. And you must be able to communicate with the rest of the network. So obviously the load balancer needs to connect to your clients, and then it needs to connect to your servers. Importantly though, it doesn't have to be in line of your servers. So they're often easy to deploy and easy to test and manage, because they can just sit on your network or in your cloud, whatever it might be. And when you actually finish deploying it, when it's actually in line and running, this is what it will typically look like. So here we see the example for www.snapt.net. And what that's pointing to is a floating IP, so an IP that's highly available on the two Snapt devices that you see in the middle. And those are then dispatching requests to your website. Now, this can scale obviously into the hundreds of web servers, and you can need to scale your load balancing or ADC horizontally as well. So you have multiple devices that are all active and so on. But in your general use case, you've got clients connecting to a Snapt server and Snapt connecting to your web servers, and you ensure that all the sort of paths along the way there are highly available and provide redundancy, etc. Now, load balancing in action at New Analytics, right? So New Analytics has been a client of Snapt's for some time. They have quite a lot of experience with Snapt, and luckily Jake, who's joining us, has a huge amount of experience with Snapt, has been using it for quite a few years. They use it for high availability for their critical services to prevent intrusions and information disclosure. So these are components of the ADC, which will address, more detail on what's available in the ADC and the market trend to the ADC and everything shortly after, Jake. And they use the support from us, obviously. So one of Snapt's big pushes and claims to fame is our support staff and support system is very quick, and hopefully Jake will talk about that a bit. And the Snapt comes with a full API and can be self-deployed. It's very flexible, very easy to use, make changes to, things like that. So at this point, let's just get Jake. I think he's currently muted. So Jake, if you could come on for us and maybe just give us sort of a bit of background on what you guys use Snapt for, how your experience has been, any highlights on it, and why you decided to settle on Snapt, I guess. I think Jake is ready, so go right ahead.
Yeah, thanks, Dave. Yeah, hi. Thanks for having me on today, and hopefully I can provide some insight on how we use Snap here. So yeah, we've been using Snap for almost 2 years now, and currently running the Enterprise Edition. We got two VMs and HA in our production environment, and the same in our DR environment. And that was a having the DR option and standby was a huge feature requirement when we were looking, and it's been working out perfect for us. Another few reasons that we needed Snap in our environment were the ease of balancer configuration, change control, and the web application firewall. Before Snap, we had two CentOS boxes that I've configured manually, HA proxy. It was a little time consuming in addition to ensuring like configs didn't have typos. Could be kind of a pain. And having Snap, it kind of took the guesswork out of any misconfiguration and typos with just simple clicks in the GUI. And provided us with options that I really didn't even know were available, and started creating backend sites and getting a lot of features that we had no idea that they were there. Another plus is change control. We're a PCI 3.2 shop, so change control is a must. So when any user admin logs in, makes a change, it's recorded, and that record's kept on who's made them. So that's been a big feature as well. And lastly, I guess another PCI requirement that we have is the web application firewall. Like I was saying, it detects and blocks against SQL injection and other known web attacks. We've also had requests for some of our customers' sites to be whitelisted for their public subnets, so only they can access their sites. This allows us to create a whitelist on the web application firewall, set it to the an accelerator front end, and limits us from having to access more public IPs on our side and making firewall changes. Another great thing is Snap support. I mean, I've emailed them late at night, and within a few minutes, usually someone's right there with an answer for me. So um, I know it went pretty quick. I got a ton of other things I know we use Snap for, but hopefully a few of those helps anybody else out with what they're looking for. But it's been a huge benefit for us.
Great, thanks, Jake. I appreciate that. There were a couple of nuggets in there, I think. I mean, the one big thing you mentioned is PCI compliance. So, as I think a lot of our viewers will be aware, obviously PCI compliance is getting bigger and bigger in more and more industries, and load balancing and web application firewalling, and that is like a core component of that. So that's great, and it's good to hear about the support as well. The interface, that's one of the nice things about Snapt, is that it's very easy to use. I mean, I think Jake, you can confirm, but it's quite easy to get up and running, and so you found that to be like a good balance of power and ease of use, I suppose.
Yeah, very. I mean, yeah, compared to a couple of years ago when I was configuring everything manually with all the config files, now it's just a lot of simple clicks of a button or options, and it's been very easy in the GUI. I remember having to do SSL certificates and loading the PEM files and everything for our sites for HTTPS, and with Snapt, it's very simple as far as adding a certificate on the front end for that as well.
Great, thank you. Okay, cool. So thanks again, Jake, for giving us some background and some use cases. What, like I was saying, it's quite interesting. Some of Jake's highlights are really around the more ADC space, whereas their initial need with us was load balancing, which actually plays quite well into the rest of the kind of topics that I wanted to talk about, the move to ADC and what it means and all of that, as well as interesting hearing, just about the ease of becoming PCI compliant for services you have that may not be. So things like an ADC can help a lot with compliance issues, as well as, you know, the actual security trends that are behind those compliance requirements. And he also mentioned DR. So one of the nice things about Snapt is that our enterprise packages, for example, come with 2 licenses for high availability, but also you can get DR licenses included in those packages. So, you know, you get like everything you need for full high availability. There's not like a need to purchase 4 devices or anything like that, which is often a highlight, I think, for clients here. But so the continued move to ADC mentality. So this is what I've been talking about quite a lot. And when we look at the service that you're load balancing, or the services as applications, as opposed to just a networking transaction, that's really what I think is the core of application delivery and the space that we're involved in, and the way the load balancing world is going. So ADCs focus on that application as a service. So it's no good at being online if it's terribly slow. It's no good at keeping it online when it's under attack or has been, you know, hacked into. Or so if, you know, you're going to keep something online, you need to make sure that it performs well. You need to make sure that it's secure. You need to make sure that the users have the best experience they have, and that is a broad topic. You know, we often throw examples around like how page speeds can scare users off from completing a shopping purchase. If a page speed loads slowly, you lose like between 25 and 35% of your users every second that a page takes to load. And there's a lot of things like that that people don't realize that are actually critical factors of the success of a service, right? And so this shift from providing just scaling and availability to really treating these applications as critical services is where we see the market going and where the market is headed towards. And that's the ADC space. So to keep your service online, to keep it safe, and to make it perform better. And the kind of key factors in there are that it's primarily web focused. So like I was saying, the majority of your application traffic nowadays is flowing over HTTPS. So your APIs, your apps, your mobile, your email, your, you know, even this app we're using right now, the screen share, is an HTTPS web app that will be going through a load balancer somewhere. Unfortunately, BigMark is not a client of Snap's, but soon, I'm sure. Delivery of availability is the second component. So delivering the best service is the focus, and availability is just a component of that. In reality, in real terms, a server going down doesn't matter. The entire site being slow for everyone does matter, because if a server's offline, the rest of the servers will take over. You know, that's the fundamentals of a load balancer, but really ensuring that that service is consistent and you know, stays available as opposed to just online. And then adaptive scaling. So this is a big trend as well now. As many of you who are cloud clients and even VM clients will be aware that load patterns and the resource usage for those load patterns are very variable nowadays. So you have auto scaling, bursts of traffic, things like that. So we see a lot of clients that are in media, for example, and you know, they may need 3 or 5 web servers to run their media site until they break a big story, and then they need 200, but can't possibly have that many. So ADCs allow you to handle bursts of traffic you didn't expect. They allow you to scale with load, you know, spin up additional web servers when you need, do additional caching when you need, things like that. So it really all centers around looking at that business critical service and ensuring that it stays online, performs fast, and stays safe, basically. Now, in summary, some of the important things we've covered here. So virtualized load balancing, so you know, cloud, VM, whatever it might be, allows you to easily scale and provide redundancy for your business critical applications. So that's the core factor of this, and that's how the diagram looks. That's how, you know, this initial one we were looking at here, that's really the focus of the service, is to ensure that you stay online and that your servers stay online and that everything functions properly and that you're fault tolerant and that you can scale as you grow as a business or as a service. Using an ADC allows you to monitor and improve your application's performance and security. A key component, I often tell people that 20% of what we do is ADC and 80% of it is visibility. Really getting a lot of visibility, reporting, proactive alerting, information, and things like that about this business critical service that you have is a key factor, I think, in a decision around load balancing and around building out a service and scaling it. Many of you will know that as soon as you start to scale a service, you get problems like someone saying, When I use my Android phone to log in, sometimes at night when I'm at home, I get a 500 error, but it doesn't happen at the office. And problems like that are a nightmare to deal with. You need something that's really looking at the data, watching for anomalies, alerting you, telling you things like, server 3 is responding slower than the rest of the servers and so on. So it allows your staff to scale as well, not just your bare metal, essentially. It's important to ensure high availability of your load balancer as well. So cloud providers on average have about a 2% yearly failure rate. So 2% of their systems are going down a year, give or take. Even if it's half that, the idea is that there's a reasonable chance that you will have a failure on one of your servers, and that may be on the server that's running your load balancer. So you need to ensure that the load balancer ADC is also highly available, that you have a pair, that you have a backup situation, you have a disaster recovery situation set up. And the final point is that Snapt does offer a free load balancer trial, so you can get a no commitment trial of the product, test it out, and you can have it up and running. Like Jake said, it's very easy to use. You can be up and running in minutes, and we're happy to help you test it out, kick the tires, and learn more about load balancing and how you set it up. It's very easy to set up and simulate in a lab because you can point to any servers, so you can point to your company's public website and load balance that. And it's very quick to get up and running. You can download a VM image and use it. So if you do have any interest in it, feel free to go to the site. You can get the free trial. Otherwise, we're also happy to help with questions, whether they are about Snapt or not. You feel free to contact us at sales@snapt.net. And then if you've got any questions and answers, you can feel free to ask them if you haven't already. We do have some already lined up, I see. So yeah, feel free to type them. You go to the questions and answers tab, and you type in what you need, and we'll get through them. I'm just going to get it open here so we can start answering them. Okay, so so the first one is what about co-location and load balancing to different data centers? So I think this was asked a bit ago in the middle, but it's a good question. So what you have is you have a pair of load balancers, like we were looking at that one example. And if a load balancer fails, it handles it. If a bunch of web servers fail, it handles it. But what if the entire site was to fail? If your whole data center went offline, or at least your whole rack, or wherever you had a failure big enough that the load balancers both went down. That's the type of situation we call co-location or disaster recovery, something that Jake was also talking about. And what you'll typically have is a mirrored setup, maybe lighter in scale or something like that, but somewhere else in the country or another physical location, whatever it might be. And for that, you would generally use a technology called GSLB, so Global Server Load Balancing. And what that is an intelligent DNS service. So because if you have a load balancer on premise, eventually there becomes a situation where a site failure will just take everything out anyway. So what you have in that situation is a GSLB at each of your two sites. And that GSLB is able to respond to DNS requests for your domain, but not just with two servers. Instead, it does smart DNS. So it will do health checking and only respond if that server is up. It can do things like say, okay, route American clients to an American server, European clients to a European server, but if the European server is down, then send them to the American one, things like that. So that's called a GSLB. Snapt does provide a GSLB, and there are other providers of GSLB. And also, many cloud providers provide some function of intelligent DNS, like Route 53 on AWS or so on. So that's how you would solve that type of problem. I see there's another one here. Oh, can you get a copy of this presentation? Yes. So you can. There is a handout available. And then also after the end of the presentation, you'll be given a link where you can watch the recording, share it, anything like that you want to do. So you can see it at any time. How does one go about replacing an old load balancing solution with something like Snapt without downtime? Okay, so if you have a more basic existing load balancing installation, the nice thing, like I was mentioning earlier, is that you can set up a load balancer, any load balancer really, without putting them in line. So they can just hang off of your network. You can send traffic to them directly on their IP address and test that everything is working. And then you essentially just do a cutover when the time is right. So you'll have an IP address on your current load balancing or whatever it might be, and you will then move that to a virtual IP on the Snap device, for example. Alternatively, if you don't have a solution you want to put this in, you would set up a virtual IP, test it manually, and then point your DNS to that service. So it's quite easy to change over without downtime. And also, obviously, we can help you with that, and consult for your specific example. Okay, advanced load balancing. Your advanced load balancing slide talked about different services. Should these not be done on different load balancers? So absolutely they can. ADC can also be split up onto different devices as well. So you can have an accelerator on one pair of servers, load balancers on another, your WAF on another. Because of obviously scale, you might want to do that. In terms of whether it's best for the device or the network or the type of layout or whatever, to have something like, I think my example used your website and an Exchange server. That's not a problem at all. What we often see is that clients will separate them either because of the amount of load that they each have, or because of a network-related design. So you want it in a different physical segment of the network. You don't want to set up VLANs. There's some, whatever the reason might be, perhaps it's in a different rack or something like that. So you want them physically separated. But in terms of it being necessary, it's not. So you can certainly run multiple services. You can obviously run many websites on a single load balancer, but you can also run your Exchange or your database or whatever you might want on the same server. That's not a problem at all. Okay, can you run Snapt on? Okay, yes. So can you run Snapt on a standalone server? So I assume that means on a bare metal server. So yes, you can. We provide an ISO image, and you can just load that, run it, and install it on any device. So Snapt can be installed in any cloud, any VM, or any bare metal device, but it can also run on any existing Linux server that you have. So if you have like a Red Hat contract with all your servers are Red Hat, you can run Snapt on Red Hat, for example, or whatever it might be. That's just one example. Okay, one more sec. Okay, great. I think that's about it for us. So that's the end of our Q&A. Thanks again from me to Jake, and thanks everyone for attending. I'll hand it over back to Nadine just to finish off. But again, I'm always happy to help. So if you get in touch with our team anytime, we're always happy to chat if you have something specific.
Great, thanks a lot, Dave. Yeah, that's a wrap on our webinar today. Thanks everyone for joining. Really appreciate it. Jake, thank you so much for your time and for joining us today on behalf of Snapt. We really appreciate it. If anyone has any outstanding questions or would like to get in touch with a member of the Snapt team, please feel free to email us at sales@snapt.net. And yes, as Dave mentioned, the webinar, this presentation will be available directly afterwards on the Snapt Academy on the Big Marker site, and you can also keep a watch out for it on our Snapt blog. Great, I think that's a wrap. Thanks everyone again. Hope you have a great day. Bye-bye.